Hi, geometry scholars. Here we are at 8.4 proportionality theorems. So this is sort of the culmination of this chapter, and we are going to go over 4 theorems so far, of which you will be able to use this theorem and its converse. Of course, we'll do other live examples under the camera, but the previous vocabulary is corresponding angles, ratio, and proportion. So let's go. Here's the first theorem. Theorem 8.6 says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So in this case, TU is parallel to QS, and it's cutting those two sides in parts. And so if you have that they're parallel, like those red markings, then you can also write this proportion. You can write RT divided by TQ. So this part over this part, and that will equal RU over US. So that corresponding part to that corresponding part. But wait, there's more. The converse of it is also true. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. So if you have this picture here on the bottom, and you can write that RT over TQ is equal to RU over US, like if they both equal the same thing, then you know that TU is parallel to QS. So we'll use that fact to solve a problem. Here's how you find the length of a segment.
In the diagram, segment QS is parallel to segment UT. RS is equal to 4, ST is equal to 6, and QU is equal to 9. What is the length of segment RQ? Solution. You were given segment QS is parallel to segment UT, and the triangle proportionality theorem states, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So, by the triangle proportionality theorem, RQ divided by QU is equal to RS divided by ST. Substitute 9 for QU, 4 for RS, and 6 for ST. And this gives you RQ divided by 9 is equal to 4 divided by 6. Multiply each side by 9 and then simplify, which gives you RQ is equal to 6. So the length of segment RQ is 6 units.
Hopefully you followed that well. If you had any problems, pause and go back and watch it again. Okay, this is monitoring progress is the problems I put on our live notes in class. But the thing about the proportionality theorem, it also implies the negatives. So you can also do the contrapositive of the triangle proportionality theorem. Remember, if the original statement is if P then Q, then the contrapositive, if not Q, then not P. And what that means is if this proportion is not equal, then they are not parallel. And you also have the inverse. If they're not parallel, then the ratio is not equal. And you can use that fact equally to show this real-life example of why this shelf is not parallel.
On the shoe rack shown, BA equals 33 centimeters, CB equals 27 centimeters, CD equals 44 centimeters, and DE equals 25 centimeters. Explain why the shelf is not parallel to the floor. Solution. The contrapositive of the triangle proportionality theorem states that if a line does not divide two sides of a triangle proportionally, then it is not parallel to the third side. So find and simplify the ratios of the lengths. First, find the ratio CD divided by DE. Because CD is equal to 44 and DE is equal to 25, CD divided by DE is equal to 44 divided by 25, or 44/25. Next, find the ratio CB divided by BA. Because CB is equal to 27 and BA is equal to 33, CB divided by BA is equal to 27 divided by 33, which equals 9/11. Because 44/25 is not equal to 9/11, segment BD is not parallel to segment AE by the contrapositive of the triangle proportionality theorem. So the shelf is not parallel to the floor.
So you can use it either way, positively or negatively. We're going to keep going. Again, live examples under the class. notes, we're not doing constructions, so I'm skipping that part. I'm going to go on straight to Theorem 8.8. And this is kind of fun because state tests like to put this thing on here, like, or for an SAT or something. So it looks like a very busy picture, but it's not too bad. If 3 parallel lines intersect 2 transversals, so your parallels here are RST, and your transversals are L and M. Then they divide the transversals proportionally. So if you know these are parallel, and you've got 2 transversals, then you can write UW over WY is equal to VX over XZ. You can write that proportion and know that they're equal. There's an example 32 in your book if you'd like to see the proof of that. In the meantime, this is how you solve a problem.
In the diagram, angle 1, angle 2, and angle 3 are all congruent. GF is equal to 120 yards, DE is equal to 150 yards, and CD is equal to 300 yards. Find the distance HF between Main Street and South Main Street. Solution. Corresponding angles are congruent, so line FE, line GD, and line HC are parallel. The 3 parallel lines theorem states, if 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Because line FE, line GD, and line HC are parallel, the transversals FH and EC are divided proportionally. There are different ways you can write a proportion to find HF. Method 1. Use the 3 parallel lines theorem to set up a proportion to find HG, then use the segment addition postulate to find HF. Using the 3 parallel lines theorem, HG divided by GF is equal to CD divided by DE. Substitute 120 for GF, 300 for CD, and 150 for DE. This gives you Hg divided by 120 is equal to 300 divided by 150. Multiply each side by 120 and simplify. And this gives you Hg is equal to 240. By the segment addition postulate, HF is equal to Hg plus GF. Because Hg is equal to 240 and GF is equal to 120, Hg plus GF is equal to 240 plus 120. Which equals 360. So the distance between Main Street and South Main Street is 360 yards.
Now that's one way to do it. Here's another way.
Method 2. Set up a proportion involving total and partial distances. Step 1. Make a table to compare the distances on line CE and line HF. By the segment addition postulate, the total distance CE is equal to CD plus DE. Because CD is equal to 300 and DE is equal to 150, CE is equal to 300 plus 150, which equals 450. You are trying to find the total distance, HF. The partial distance, DE, is equal to 150, and the partial distance, GF, is equal to 120. Step 2. Write and solve a proportion. Using the information from the table, write the proportion 450 divided by 150 is equal to HF divided by 120. Multiply each side by 120 and simplify, and this gives you 360 is equal to HF. So the distance between Main Street and South Main Street is 360 yards.
So in a perfect world, you can do this both ways. Either find that smaller part, GH, and then add it to FG, or you can write small part to large part equals small part to large part. Just pick which way you want to do it. There's one more theorem, and this one is involving an angle bisector, so you'll get plenty of chance to practice with this. And this example has a really good tool for you to use, so pay attention. If a ray bisects an angle, so if you get that both of these angles are the same, then it bisects it. Then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So if you have this situation, then you can write AD over DB, that ratio, is equal to AC over BC. And so that you can write that proportion. And again, solve it. There's an example 35 in your book. Of course, we'll be doing one more example.
In the diagram, angle QPR is congruent to angle RPS. Use the given side lengths to find the length of segment RS. Solution. Because ray PR is an angle bisector of angle QPS, you can apply the triangle angle bisector theorem, which states if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Let RS equal x. Then RQ is equal to 15 minus x. By the triangle angle bisector theorem, RQ divided by RS is equal to PQ divided by PS. Substitute 15 minus x for RQ, x for RS, 7 for PQ, and 13 for PS. And this gives you the quantity 15 minus x divided by x is equal to 7 divided by 13. Next, use the cross products property, and 195 minus 13x is equal to 7x. Solve for x, and 9 7/75 is equal to x. So the length of segment RS is 9 7/75 units.
So in particular in this example, even though you're given the whole part and you're looking for just part of it, that means the rest of it is the whole part minus the part, 15 minus x. So this is a really powerful tool that you'll use all throughout algebra. Again, if there's any parts you didn't understand or you're not sure about, we're going to be doing more in class together, and make sure you have questions. But for now, you're done. And good luck.